Okay, for question 6 here, what we'll do is we're going to go through I all in one shot, and we'll go through II, or 1 and 2 here. So for this first one here, we're supposed to find the critical numbers. Okay, so what we're going to do here to find our critical numbers, that involves finding the derivative of this function, in which we get 4x cubed, okay, minus 64x. And then your critical points are going to be all points in the domain of the function where the first derivative is equal to 0 or undefined. So in this case here, I've got this cubic here that I'm going to factor by taking out the common factor of 4x first, and then this gets me x minus 4, x plus 4, and so my critical points are going to be 0, 4, and negative 4, and those are all inside the domain of the function because the function's a polynomial, and so it's defined basically everywhere. Now, I can see that my derivative is a cubic. Okay, more specifically, it's a positive cubic with these roots, meaning that it's going to go through negative 4, 0, and 4, and it's going to look something like that. Okay, so what does this mean for me? Well, this means that my original function is going to be decreasing wherever the function is negative, increasing where it's positive, and then again decreasing here and increasing here. So the whole function is therefore increasing on the domain negative 4 to 0, union 4 out to infinity. That's where the derivative is above the x-axis. And it's decreasing on the interval negative infinity to negative 4, union 0 to 4, because those are the intervals, and I can see that from my little graph here, where the function is negative, where the derivative is negative, meaning that the function will be decreasing. Now the question says, find the coordinates of the points that are maximum, where the maximums and minimums occurs, and determine if the points are maximums or minimums. Well, now that I see this right here, I can tell you right now, because I'm decreasing and then increasing around negative 4 must be a minimum. So we're going to get a minimum at negative 4, and then to get the y coordinates, I simply go back up to the original function and evaluate it. Now I've already done that for us, so I'm just going to put that value down there, negative 261. 0 on either side of 0, I'm increasing to the 0 point and then decreasing afterwards, which makes that a maximum point. And then again, I'm going to take my 0 and plug it back up into the original function, and that's going to give me the maximum value of 5. And then one more time I take a look at this, and I can see that on either side of 4 I'm decreasing and then increasing, which means this is going to be a minimum. Okay, plug that 4 in, and again I plug that into my original function, and I see that the y coordinate is negative 261. So that's all the information that this question is asking for.